Okay, so in this example, we're going to be talking about how to solve log equations. Now, before we start this video, you have to know how to do properties of logarithms. If you do not know properties of logs, I have a video on that, so I'll go ahead and link that below. That way you have access to that content. So again, please make sure you know about properties of logarithms before trying this video. But assuming you know those properties, let's go ahead and talk about how we're going to solve these log equations. So our first example here, you can see that we have log base 4 of 26 equal to log base 4 of 6 minus 4r. Now this one here is going to be very, very simple. Whenever you have an isolated logarithm equal to another isolated logarithm and your base is the same, the logs will essentially cancel out. So for example, I have an isolated logarithm here and I have an isolated logarithm here. They both have the same base of 4, okay? That means these logarithms are going to cancel out on both sides. So for example, this will cancel and this will cancel, and I'm going to be left with 26 equal to 6 minus 4r. And from here, all I have to do is solve for r. And this works out because if I balance out the bases on both sides, the logarithms will essentially cancel out because of the inverse property. So for example, I could do 4 all to the power of log base 4 of 26 and set this equal to, well, since I changed the base here to 4 on the left-hand side, I also have to do that on the right-hand side. So I would write 4 to the power of log base 4 and then of 6 minus 4r, okay? So again, we're just manipulating the equation here, and you can see that now I have the inverse property, and this will cancel, and this will cancel, and you can see I'm left with what I have right here. But all you have to remember is if you have a logarithm isolated on both the left-hand side and the right-hand side, and they have the same base, they will cancel out. And this right here is why that happens, okay? So all we have to do now is solve. So why don't we go ahead and get rid of all this stuff here, and we're going to solve for r, okay? So solving for r, we're going to go ahead and minus 6, okay? Minus 6. This will cancel. Here I get 20 equal to negative 4r, okay? My last step, I have to divide by a negative 4. So dividing by negative 4, okay, this will cancel. I get r is equal to negative 5. So r is equal to negative 5, all right? And that there is going to be our final answer. Now, it's always a good practice to make sure you're not dealing with an extraneous solution. So for example, you can take this negative 5 and plug it back in wherever you see an r. So remember, if you have a logarithm written as log and then you have base of x, okay, your x value can never be 0 or negative, otherwise it's going to be extraneous. So if I take this negative 5 and plug it into r here, will I get a 0 or a negative number? Well, negative 5 times a negative 4 is positive 20, and then I'll do 20 plus 6, I get 26. I'm good there. This solution will work, all right? So again, it's good practice to check the solution to make sure it is not an extraneous solution, all right? So let's go ahead and take a look at our next example. So here's our next example. This one here, we're dealing with natural log, but again, it's the same deal. We're going to be using properties of logarithms. And just remember, a natural log always has a base of e. So even though they did not write the base here, both of these natural logarithms have a base of e, okay? Now, notice the property that we're going to be using here. I have subtraction. So if we have the same base, which in this case we do, we have a base of e, we're going to end up condensing this down by dividing. So for example, I'm going to condense down this whole left-hand side before I try to solve for anything. So I'm going to write natural log, and I'm actually going to put the base here even though they did not write it. So I'm going to put base e of, and then going left to right, I have 6. The subtraction sign means division, so divide by x minus 2, okay? There we go. And this will be equal to natural log, and same thing, I'm going to put base e here, okay, of 38, okay? So what do you notice is going to happen here? Well, just like the first problem, if you have a logarithm isolated on both the left-hand side and the right-hand side, and you're dealing with the same base, they will cancel out. And I should have mentioned before, that's called the one-to-one property. Okay, so I think I forgot to mention that. That is called the one-to-one property. So you can see here, I have a natural log isolated on the left-hand side. I have a natural log isolated on the right-hand side. I have the same base, meaning they are going to cancel out. So this will cancel, this will cancel. Now I'm left with 6 over And I'm going to put these two terms in parentheses, x minus 2 equal to 38. From here, all we have to do is solve for x. So what I'm going to do first, I'm going to multiply both sides by x minus 2. Okay, so multiplying both sides by x minus 2. All right, that will cancel here and here. Now you have 6 is equal to 38 times x minus 2. So you only have two more steps. All right, so your first step, divide both sides by 38. And then your last step, add 2. So for example, if I divide by 38, I get 6 divided by 38. And then I have to add 2, so plus 2, and this will be equal to x. Okay? Now, technically you could leave it like that, but we should probably get a common denominator here. So again, this 2 here is really over 1. So what I can do here is rewrite it as 6 over 38 plus, and how am I going to get that common denominator of 38? Well, I'm going to have to multiply this guy both top and bottom by 38. So doing that, I'm going to do 2 times 38, and that will give me 76 all over 38. And then from here, I just have to do 76 plus 6, I get 82. So I get 82 all over 38. Okay. And then we know that 2 will go into both of these numbers here. So 2 will go into 82 41 times. So I get 41, here's my final answer, 41 over, and 2 will go into 38 19 times, okay, right here. So that is what x is going to equal. So x equals this part here, all right, 41 all over 19. So you want to do the same thing as we did on the other problem. Plug it in to make sure you're not dealing with an extraneous solution. So if I plug it into x, will I end up with a negative or a 0 for my x value? So for example, if I have ln of x, I don't want this part to be negative or 0, otherwise it's not going to work, okay? Now, if I plug this in, that will not happen here because 41 over 19 is 2.15. And so if I plug it in here, that is not going to give me a 0, and that is not going to give me a negative number, so I'm good. This will work. All right, so why don't we go ahead and look at another example. So here's our next example. This one we're dealing with a log, and it has a base of 3. Now we want to condense it down before we try to solve for x. I'm dealing with addition. So using properties of logarithms, if I have the same base and I'm adding, I can multiply, okay? So rewriting it, I'm going to have log and then base 3 of, now I have to multiply x plus 7 times 10. So if I do that, I end up getting 10x plus 70, right? Remember, you have to distribute that 10 to both of your terms there of x and 7. So you get 10x plus 70. Okay, that's good, all equal to 3. What do I do from here? Okay, this one's a little bit different because I have a logarithm on my left-hand side, but I do not have a logarithm on my right-hand side. I can't use that one-to-one property where the logs will cancel out, but we can use the inverse property. And the inverse property states if I have a base that matches the base of my logarithm, they will cancel out. So I can go ahead and manipulate the equation, rewriting it as 3 to the power of log base 3 of 10x plus 70, okay? And since I did that to the left-hand side, I also have to do it to the right-hand side. So now this value right here is going to have a base of 3. So I'm going to write 3 to the power of 3, just like that, okay? And now the inverse property can be applied right here. That will cancel. I'm left with 10x plus 70 equal to 3 cubed is going to give you 27. All we have to do from here is solve for x. So I'm going to minus 70 on both sides. Okay, 27 minus 70 will give us negative 43. So I'm left with 10x equal to negative 43. And then my last step, divide both sides by 10. So x is equal to negative 43 all over 10. And we can leave it like that. Okay, that's done. Again, you should check for an extraneous solution, make sure it works. If I plug it into x, will I end up with a negative or a 0? So again, the only x I have in the problem is right here. If I plug that in, will it make it 0 or will it make it negative? And it will not, because we know that negative 43 divided by 10 is negative 4.3. And again, that will result in a positive number when I add 7 to that. Okay, so we're good. This solution checks out. All right, let's do 2 more examples. So here's our next example. We're dealing with a natural log, meaning we have a base of e. Okay, they did not write it, but again, we know that technically there's a base of e there. Now I'm dealing with addition, meaning I'm going to multiply. So I'm going to rewrite the whole left-hand side as a single natural log. So I'm going to write natural log, and I am going to write the base of e, that way we can see it, of, I have to do 9 times 2x, that will give me 18x. And then I have to do 9 times a negative 7, that will give me negative 63. So negative 63 equal to 2. Okay, so how do we do this one? It's just like the other problem. We don't have a log on the left-hand side and the right-hand side. We can't use that one-to-one property, but I can rewrite it with a base of e. That way the inverse property can be applied. So for example, I'm going to write the left-hand side with a base of e. I'm going to say e to the power of natural log base e of 18x minus 63. This will be equal to, remember, you have to balance it out. I rewrote the left-hand side with a base of e. That means the right-hand side also has to be written with a base of e. So e to the power of 2. Now we can apply the inverse property. This will cancel because I have a base of e and my natural log has a base of e. So again, the inverse property can be applied here. And now I'm left with 18x minus 63 equal to e to the second power. And from here, you just have 2 more steps. You have to add 63 and then divide by 18, right? So if I add 63 and divide by 18, I'm going to be left with x is equal to e to the second power, add that 63, and then divide by 18. Done, right? So this problem right here is now complete, okay? And again, you should check that for an extraneous solution. You can plug that into your calculator to get the decimal value of x, then actually plug it into x. But I'll just tell you right now, that will not lead to an extraneous solution. This will actually work. All right, let's try one more example. So here's our last example. We're dealing with a logarithm. Now, they don't write the base on this logarithm, but just like with a natural log, if you don't see a log with a base indicated, that means the base is going to be 10. That's like the default. So you can write a logarithm with no base, but it's assumed it's going to be 10. So my base here is really 10, and I'm dealing with subtraction, okay? So I'm going to rewrite this as a single logarithm. I'm going to say log base 10 of 5x minus 1. And again, since I have subtraction, I'm going to divide. So divide by 2, right? Close it, equal to 3. So again, just like the last 2 problems, we're going to have to go ahead and adjust the base here. That way we can apply the inverse property. So I have a base of 10 right here, meaning on the left-hand side, I'm going to rewrite it with a base of 10 so I can apply that inverse property. So I'll have 10 to the power of log base 10 of 5x minus 1 divided by 2. This will be equal to, we do have to balance it out, so this is going to be 10 to the third power. So 10 to the third power. Now, inverse property can be applied here, so this will cancel. I'm left with 5x minus 1 divided by 2 equal to, we know that 10 to the third power is going to be 1,000, so I'm going to put 1,000 here. And now all we have to do is solve for x. So my first step, I want to multiply both sides by 2. That way I can get rid of this denominator. So that will cancel here. I have to multiply over here by 2. That will give me 2,000. So I get 5x minus 1 equal to 2,000. Okay, 2 more steps. I have to add 1 and then divide by 5. So I get x is equal to, adding 1, I get 2,001. Okay, and then divide by 5. And there we go. So this is going to be my final answer. Okay. And again, you should check for an extraneous solution, but it's clear that I'm not going to be dealing with a 0 or a negative number if I plug this value back into x right here. Okay, so we're good. This solution will work. So that is how you can solve equations dealing with logarithms. You have to have knowledge and properties of logarithms though. So again, if you do not have that knowledge and properties of logarithms, go ahead and check the video below. I'll go ahead and link it. That way you have access to that content. And that's pretty much it. So if you gained anything from the video, or if the video helped you in any way, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.